last 30 years, Transverse and Technigas have gained the reputation of leading specialists in naval engineering for the transport of liquefied natural gas, LNG. Today, it's the only company in the world able to design membrane-type methane carrier tanks. Through constant efforts in research and development, GTT have continually improved these systems both in terms of performance and reliability. To further technological development, Transverse and Technigas conduct numerous laboratory tests. These tests, performed in different specialized centers, one of which is part of Transverse and Technigas, evaluate the characteristics of materials and the partial assembly used. Due to the transport temperature of LNG, -163 degrees centigrade, it's essential to test the material in cryogenic conditions to check their mechanical and thermic characteristics as well as their behavior at very low temperatures. Other tests are conducted on reduced scale models to simulate the motion of liquid in ships' tanks, thus providing a closer evaluation of hydrodynamic forces on the walls. By taking these results into account, Transverse and Technigas can optimize the design and quality of membrane systems as well as their implementation. In the membrane tank concept, the double-hull ship structure is used as a basis for a tight, heat-insulated cryogenic lining. The membrane gives the tank its impermeability to gas and liquid, whereas the load-bearing insulation system transmits the LNG loads to the hull and limits the cargo boil-off rate. Transverse and Technigas have developed two membrane systems based on this concept which use different types of materials. Is the NO96 system. On completion of the ship's double hull, the tanks are equipped and set up as full-scale all-weather workshops. To allow for access along the walls and ceiling, the first step is to erect scaffolding in each of the tanks. It has several levels, allowing vertical and horizontal circulation, and there's wide storage and handling area on the floor of the third level, which is directly accessible through an opening in the ship's hull. Very precise topographical measurement of the inside surface of the tank, as well as of the defects in flatness, is carried out with laser equipment connected to portable computers. The coupler bases are positioned using a laser sensor. They're then welded by an automatic welding robot. The couple of bases represent the mechanical bonds of the NO96 system. They're fitted in a rectangular 1 metre by 1 metre 20 grid. On the basis of the dimensional survey taken previously, the defects in hull flatness are compensated vertically at each base by fitting reference wedges from 4 to 15 millimetres thick, which have been calculated by computer. In this way, an ideal surface is obtained using these reference wedges, which smooth out any hull deformation and serve as a reference for the fitting of boxes. Along the tank transverse corners, 8 mm thick anchoring flat bars are welded to the double hull. These bars transfer induced tension to the hull in each of the metal membranes. While all this is happening, the prefabrication of insulating boxes has begun. These plywood boxes are assembled to very precise specifications by a highly automated industrial woodwork manufacturer. Staples are used for the assembly. The boxes have inside partitions which give them great mechanical resistance. The boxes are then filled with perlite, an insulating mineral powder, and vibrated before being closed up, packed and sent to the tanks. These boxes represent the insulating part of the cryogenic system. Before assembly, resin ropes are applied on the back of the secondary insulating boxes. This operation is performed by an automatic coating machine which calibrates the ropes and puts them precisely into position. Rope thickness varies between 10 and 20 millimeters. The resin ropes are flattened when the boxes are put into place. They compensate for any level differences and balance out the bearing loads of the boxes. A craft paper foil is then applied to these ropes in order to stop them sticking to the steel of the double hull. T-groove on their surface every 500 millimeters, into which a continuous metal tongue is placed along the length and width of the tanks. The tongue is made of invar material, 0.5 of a millimeter thick. It's automatically and continuously unwound, folded into an L shape and inserted into the box grooves. This is the mechanical bond for the secondary membrane strakes. The tongues guide the positioning of the secondary membrane strakes. As for the tongues, invar strips 0.7 of a millimeter thick are delivered in coils which are automatically and continuously unreeled and unwound along the length and width of the tanks. When the invar strips come off the reel, the edges are folded and lifted up at a right angle to make 500 millimeter wide strakes. These fit perfectly between the two adjacent tongues, equipped with temporary guides to make the unwinding easier. The strakes are held in place along the wall by means of temporary devices consisting of a hook anchored in the eyelets cut in the tongue. The strakes are then flanged into position by tack welding onto two adjacent raised edges on the intermediary tongue. This operation is carried out using a light automatic resistance welding robot. The tightness welding is then carried out by fully automatic resistance seam welding. This is done on a continuous basis all along the length of the strake. The machine progresses along the strake at a speed of 1.5 meters per minute, held onto the rail which is formed by the emerging part of the tongue. The tank transverse corners are fitted with elements called invar tubes, which are prefabricated off-site. These elements are made by folding and welding 1.5 millimeter thick invar plates. They're prefabricated into elements 3 meters long. Their prefabrication on automated assembly lines requires great accuracy. Their assembly on board is performed by the automatic welding of these invar tube wings onto anchorage bars. The tubes ensure the continuity of transmission of the primary and secondary membrane loads towards the hull and complete their tightness in the corner areas. Heat insulation of the transverse corners is completed by assembling specially shaped insulating boxes between the invar tube wings. The membrane parts, which are 1.5 millimeter thick and 500 millimeters long, called strake ends, are added and welded to bridge the invar tube wings and the secondary membrane. The strake ends are automatically welded onto the invar tubes using a TIG process without filler metal. The raised edges of the strake ends are welded manually, and a round cut is made by a pneumatic shear of the tongue and raised edges of the membrane up to the resistance welding, which ensures a perfectly tight assembly. The continuity of the secondary membrane along the tank's longitudinal dihedrons is ensured by a longitudinal composite beam on which both adjacent invar strakes of the secondary membrane are welded. They're welded automatically using a TIG process.
Place where they told you what to chase, told you how to run the race. Every move was on the page, but I didn't like their way. Had to fight and misbehave, had to find a way to change, had to leave to find my way. Caught up in a daydream, I beat my mind up there almost daily. It's how I pass time, no opinions safely. It's how I understand what I want in this place, see. Cause everybody wanna tell you bad things, what could go wrong, what fame brings. But success is a finicky thing, and if you ain't sure, no, it'll never be. I don't wanna let myself down, myself down. I don't wanna let myself down, myself down. I don't have to plan it, I can go change my fate. You won't understand it, all alone, that's okay. People, I can't stand them, they don't want me to change. Keep me where I'm standing, and I don't wanna be where I am. And I want something more, take a chance. It could be possibly my last dance, my last dance. I don't wanna let myself down, myself down.
At the end of these controls, the secondary insulation and membrane are complete. These operations will need to be repeated for the primary insulation and membrane. The primary insulation comprises a layer of insulating boxes which are similar to those of the secondary insulation, yet different due to their thickness of 230 millimeters. Grooves have been placed in the box to allow the passage of the secondary membrane tongues, and cleats are used to fix the boxes onto the collar studs using plate, washer and nut. These boxes are slightly different, for at the prefabrication stage they've been fitted with an invar tongue like that of the secondary tongue, except that it's curved and allows reinforced fastening of the primary membrane. Following the box assembly and alignment, it's easy to clip on the primary tongue, which curves in the opposite direction. The primary tongue is stretched out and flanged in this position by making a snug with this pneumatic machine. The primary membrane is next assembled in the same way as the secondary membrane. Automatic unwinding of the coiled invar sheet, folding the edges, automatic tack welding, and strake seam welding. When the welding process is completed, a new helium tightness test of the primary membrane is performed, followed by a 540 millibar vacuum test, and finally a resistance test under a pressure of 800 millibars. The tanks are then complete. Prefabricated to a Gas Transport and Technigas design, the tripod mast is taken down in one piece into the tank by liquid dome. The mast supports the pumps, highly precise level measuring instruments, the temperature sensors, and the loading and discharge lines, the upper part being connected to the piping network on the deck. The ship is now ready to deliver its first load. The double metallic membrane system, which is perfectly tight, guarantees a boil-off rate which is below 0.15% per day in cargo volume, in complete safety for the ship and its environment. In this way, the leveling washers smooth out hull deformation and determine the ideal surface the prefabricated insulating panels will be fitted to. Insulating panels are industrially prefabricated in a dedicated facility. The flat panels are prefabricated by the successive piling and bonding of a 9mm thick plywood board, a secondary insulating layer 160 mm thick made of glass fibre reinforced polyurethane foam, then bonded again onto the upper side, an aluminium glass cloth composite material sheet serving as a secondary barrier, the primary insulating layer previously prefabricated by bonding reinforced polyurethane foam and 12mm plywood. The thickness of the primary insulation is 80mm to give a final panel thickness of 250mm after assembly. The panel boards are next machined to their final dimensions. This involves cutting of the primary block. Metallic inserts are then put into place for easier handling and erection on board. Stainless steel anchor strips on which membranes will be fastened are installed, and fixing holes are drilled. The standard dimensions of the flat panels are 3 meters by 1 meter. The angle panels at 90 and 135 degrees are assembled by bonding in the same manner. 2 sandwich panels made of reinforced foam, plywood and including a secondary barrier are held by bonding the rigid composite keys made of hardwood and heavy corners in stainless steel 8mm thick, onto which the primary membrane will be anchored along the tank edges. Inside the tank before erection, the side of the panels is coated with resin patches or beads, which when flattened during the setup of the panel will allow for a proper distribution of the loads on the double hull, ensuring that the panels adhere to the structure of the ship.
You could try to play, but you're never gonna beat me. Look the other way, what I'm doing ain't easy. Bloody hands stained from the people who deceive me. Muddy hands break through the chains, go free me. Looking for change, looking for pain, pulling a mob, pushing a train. I'll never stop, stick to a lane, pick up the pieces and go rearrange. I'll be the best above all the rest, put me to the test and expect nothing less. You check as I'm chess, what's happening next? Yeah. He got the venom, a tangible weapon, no coming in second. This life is a lesson. He got a new engine from pain, that's a blessing. New focus, no guessing, just bold and obsession. All in his possession, you got their attention. I'll leave an impression and take a redemption. Just kill, no discretion. Your mind is a weapon. 11-11, it's time for progression. You could try to play, but you're never gonna beat me. Look the other way, what I'm doing ain't easy. Bloody hands stained from the people who deceive me. Muddy hands break through the chains, go free me. People like sheep, move feet, hurt it easy. You don't wanna be fast asleep when they scheming. Better stand tall, ready for a fight, believe me. When they try the chains, you can say no, free me. So he's been looking for somebody who could save him, instead of searching inside for what they gave him. A strong will, strong mind causes mayhem. We could change the world, change times, rearrange them. Staying on pace.
The secondary barrier is then completed by ensuring its continuity at the joint between each adjacent panel. Technigas membrane is prefabricated in a dedicated workshop. It's made of 304L stainless steel plate 1.2 mm thick, offering 2 perpendicular corrugations obtained by 2 successive folding operations.
Losing time, I'm fading fast. I just wanna make it last. Try to let go of the past. I close my eyes, embrace the blast. Sleepless nights and headaches stack. Restlessness to hell and back. What's my purpose? What do I grab? A slippery surface, a heart attack. And sometimes you just gotta believe there's something that'll give you relief. There's something that'll have what you need. What you need. We're broken, it's tragic. We're not all elastic, but maybe there's magic. Believe you could have it. And I know of sadness, the anxious and panic, the infinite vastness of all that is blackness. I don't really know what comes next. I'm just doing my best, even though I'm so stressed out. Everything just feels like a test that I fail, so depressed when I can't seem to get out. But something deep inside won't let me quit. I swear that I'm inspired by all this shit. Tell me that I can and I won't. That's what guides me the most. Fuck your lies, I'll do what I want. By thirst, I'm inspired by worth. I desire your worst, so you can just hide while I work. I ain't tired, you first. I'll write a second, third verse about the lies you go disperse. You never did shit, I know it hurts. Something deep inside won't let